Hi friends, welcome to my YouTube channel. Hope you all are doing good. In the part 1 and part 2 of this videos, we discussed about the introduction part of the uh, self-compacting concrete and some background and history of the self-compacting concrete, basic definitions of self-compacting concrete, advantages, applications of that. So coming to today's topic, we are discussing about the basic considerations and the concluding part of the self-compacting concrete. This is the part 3 and final video of the self-compacting concrete. If you haven't watched this part 1 and part 2 videos of the self-compacting concrete, please go and check it out in my channel, as that is a prerequisite to watch this video. Coming to the basic considerations, what are to be maintained to get the self-compacting concrete? Most specified SCC. Reduction of the coarse aggregate content in order to reduce the friction or the frequency of collisions between them, increasing the overall concrete fluidity. As we are reducing the concrete content, the coarse aggregate content over in the concrete, we are able to get a highly flowable concrete. So increasing the paste content to further increase fluidity. Okay, we are increasing the paste content and reducing the coarse aggregate content. Managing the paste viscosity to reduce the risk of aggregate blocking when the concrete flows through obstacles. So we are allowing the paste viscosity such that it is able to flow even in dense reinforcement with its own weight, that is self weight. In rheological terms, even though a significant amount of research tends to show that the self-compacting concrete's viscosity varies with the shear rate and acts as a pseudoplastic material, the self-compacting concrete is often described as a Bingham fluid, that is the viscoelastic fluid, where the stress to the shear rate ratio is linear and characterized by two constants, that is viscosity and yield stress. Okay, the stress to the shear rate ratio is linear, okay, and characterized by two constants, that is viscosity and yield stress. Yield stress is nothing but Fy of the steel. Next, back to the performance based definition of self-compacting concrete, the self-consolidation is mainly governed by yield stress, while the viscosity will affect the homogeneity and ability to flow through reinforcement. Homogeneity is resistance to segregation, whereas it should also be able to flow, that is flowability, and the passing ability, the filling ability, passing ability should be satisfied. Okay, the flowability and resistance to segregation should be achieved. As the self-compacting concrete viscosity can be adjusted depending on the application, the yield stress must remain significantly lower than other types. Okay, so we are just allowing the viscosity such that the concrete is filling in the formwork even if it is having some dense reinforcement. Coming to the applications of SCC, the application of SCC are limited to special cases where it is impossible to use ordinary concrete. The self-compacting concrete was used in the construction of two anchorages of Akashi Straits Bridge opened in 1998, a suspension bridge with longest span in the world, that is 1990 meters, was constructed. So because we cannot go for the normal concrete, we are using the self-compacting concrete. So it was the first project to utilize the SCC. Okay, we are having anchorages for this. For these bridges, what are the anchorages it is made up of? It is made up of SCC. SCC was used for the construction of wall of a large LNG tank belonging to Oscar Gas Company in 1998. The SCC has been used for the repair of a bridge built in 1960 in the Swiss Alps has also reported. And coming to the mixed design methods of the self-compacting concrete, European practice, Sedren et al., that is LCPC Paris method we have. The third method is Gomes, Ravindra Ghettu et al. Method, Nansu et al. Method, Jagdish Wengala et al. Method, the rational mixed design method, that is of SP Rao and MBS. Coming to the Efnarc guidelines, designation of desired air content, that is mostly 2%. Water to powder ratio by volume of 0.8 to 1.1. So coarse aggregate content normally 28 to 35% by volume of the mix. So these are the Efnarc guidelines. And also we have other guidelines such as water cement ratio is selected based on requirements in EN 206. Typically, water content does not exceed 200 liters per cubic meter. Determination of sand content, determination of paste composition has to be done initially. Coming to the mixing of concrete. In the process of mixing, the material is weighed with their proportions exactly, and then the materials are stacked on a watertight platform. That is, we are not allowing the water, any additional water from the surface to enter in the concrete. The materials are thoroughly mixed in their dry condition before water is added. Okay. The prepared mix was immediately used for testing the workability of fresh mix. So initially we are just mixing the dry materials, and after that we will be adding the water. Okay. And remember, we have to use a watertight platform. That is, the water from the concrete is not absorbed by the surface. It should be watertight. It should not be absorbing the water from the concrete, nor it should be wet in nature. Okay, it should be dry. Casting of test specimens. As the trial mix achieved compactability with the same mix proportions, cubes were casted when tested for 3 days strength. If it has achieved good strength, hence with the same proportions, cubes, cylinders and beams of standard sizes were cast and cubed for 28 days. Coming to the conclusion, by adjusting the contents of coarse aggregate and fine aggregate sequentially and replacing the fly ash or coarse aggregate, the self-compacting concrete can be achieved. Even without incorporation of VMA, that is, the viscosity modifying agent, also the self-compacting concrete can be achieved only with the addition of superplasticizer. Okay, even if we are not using VMA, it is good to go with superplasticizers alone. Okay, as compared with conventional concrete, the SCC gives higher strengths on long duration. Using up to 20 mm size aggregate, SCC can be effectively produced. Even though the amount of coarse aggregate reduced in SCC, the value of modulus of elasticity is almost same as that of the conventional concrete. The use of fly ash in the self-compacting concrete increases the flowability and workability. And this fly ash addition has not suffered in early age strength and continue to develop the later age strength. So initially it is not contributing to the early age strength, but it will be contributing to the development of the later age strength, that is after the hardening of that concrete. Coming to the introduction of the fiber reinforced self-compacting concrete. Coming to the history of self-compacting concrete, the latest generation concrete in 1986, Professor Hajime Okamura in Japan was proposing this. The SCC was described as the Quiet Revolution by the Concrete Society 2005 and BRE. So investigation of SCC for, we are doing this mechanical behavior, durability, microstructure, and what all the self-compactability test methods are there, structural applications of this. That is it for this video, guys. If you like the video, please like, share and comment to the channel. Your subscription would greatly help me. I appreciate you watching this video. Thank you.